What's up, kiddos? Here we go. Section 1 of Chapter 11 is called Understanding Area, and that's exactly what I want you to do in this section. Understand area. I'll be very transparent with you. Back in high school, many moons ago when I went to high school, I could find area like anybody. I mean, it was simple. You get an answer, great. But here's what I didn't understand. When I get an answer like 36 centimeters squared or 43.6 centimeters squared or whatever it was, I never understood and even cared, honestly, what the number meant. 46.2 centimeters squared, woohoo, great, I got the answer right, let's go. I want you to understand what that number really means, because throughout this chapter and the next chapter, chapter 12, you're going to be finding the areas of many different things. And I want you to understand, and it's important for you, it has nothing to do with me, it's important for you to understand what the number is telling you. So if you get an answer of 12 meters squared, what does it mean? If you get an answer of 12.2, is it anything different or is it pretty much the same? You'll find out what that's all about. So real quick, just some basics of area. Area basics, whatever. And we have the difference in units. We have something called linear units, which I'll highlight the word here, line. There's a reason why, line. And you got this word, these units called square units. Linear units we already know. We've seen this many times throughout the year, the segments. When you measure a segment, you can use meter sticks, yard sticks. You can measure them in terms of inches. It's a linear particular unit. So it could be inches, as I have here, inches, centimeters, meters, yards, feet, miles. It could be anything. When we talk about square units, though, it is an actual dimension by dimension, as you see right here. This is a centimeter squared. It's 1 centimeter squared. It's a unit, square unit, centimeter squared. It's a centimeter by a centimeter. This is an inch by an inch. Everything's a cinch. Just kidding. Inch, that's an inch squared right there, and this is not quite drawn to scale, but if you went a foot by a foot, a 12 by 12, that's a square foot. So when you look at the floor in the school, all the tiles in the floor, it's a great example, all the tiles on the floor in the school, they are an example of 1 square foot. And here's what's cool, if you look at this, it says the area of a closed region is the number of square units, that's these guys, square units, whatever they are, the number of square units of space within the boundary of a region. What does that mean? If you ask your parents what the square footage, what I just said, square footage of your house actually is, and they tell you, I don't know, 2,000, or they tell you 1,200, or they tell you 8,000, that's awesome. Whatever it is, I'll use a simple one. If it's 2,000 square feet, that means to you that if you would tile every floor in your house, I'm talking living room, I'm talking bathroom, I'm talking basement, I'm talking your room, that's dirty, it needs to be picked up probably. Just kidding, maybe not. What that tells you is you'd be able to take a foot by a foot, that square tile that you're seeing at school, you would be able to put that in all the floors of your house, and it would be 2,000 of those tiles if your house was 2,000 square feet. That's what it really kind of means to you. So that's a pretty cool thing. Here's neat too. If you remember back in social studies, or maybe even talk about it now, some of those classes, you talk about the land surface area of land, or the surface area of how much water is, the ocean or whatever. I'm thinking of just examples off the top of my head. But one I put up here for you is the actual county that we live in, Cumberland County. It talks about the square miles of how much land there is. And here's what I want you to understand. Here's what a square mile is. Think about if you started at one point and you walked in one direction, 1 mile. That's pretty far. It is. And you turn 90 degrees and you walk a mile in that direction. So you went a mile this way, and you went a mile this way. And then you turned again and went a mile this way. And you came back a mile to your spot. Think about how much space that actually is. It's enormous. Well, Cumberland County is 551 of those mile by miles, square miles. It's absurd. When you go look at how much, like the Pacific Ocean or the Atlantic Ocean, like it's an absurd amount if you really possibly fathom how big it really is. It's crazy. Hey, by the way, Mechanicsburg, Emberg, 2.41 square miles. Tiny little Mechanicsburg. How about that? So let's move on. A couple postulates for you. A couple other ideas with estimating area and how you find area. I just told you this. It's a number of little square units that you can put into a shape. Now here's the deal. Sometimes you're going to find, and you remember, you'll get answers like 13, an exact answer of 13. No decimals, exact answer of 13 meters squared. Here's why that happens. When you have a rectangle or a square, or something that has right angles all over it, you can actually place an even number, even's the wrong word, you can place an amount of squares in there that's not going to be a decimal. So you're going to be able to place a whole foot by a foot or mile by a mile, whatever it is, into that particular unit. So you can see you can just place them side by side by side by side, and you can just count them all up and you'll get the answer. That's estimating it. It's not the best way by far, and you'll see why in the next example. That triangle, I mean, look at it. You got a square unit right there, whatever it is, square inches, but it's not a whole square. So that's why you get answers sometimes like 12.36 or 12.4 or 12.5 and a not exact answer. I'm a big golfer and the Masters are coming up, so this right here is a picture of a golf green. It could be a pond, it doesn't matter, but it'd be the number of square units of whatever it is that you can put on top of the surface of the pond or on top of the surface of the green. That's what it is. Not the best way to do it, but it is the way that you can find the area. Now, just a couple quick postulates, I'll read them. Every closed region does have an area, so no matter what the shape is, it will have an area. It might not be exact, or a whole number, couldn't think of the word. It might not be a whole number, but you'll get an answer. This one right here, if two closed figures are congruent, then their areas are equal. Makes complete sense. If they're congruent, means they're the same size, same shape. Areas should be the same, and they are. This one right here, basically it says this: if two closed regions intersect only along a common boundary, then the area of their union equals the sum of the individual areas. Here's what that means. Over here on the left is a simple little picture. Here's region A, here's region B. Its boundary is that thing right there. If it bounds that particular one line along a common boundary, you can take the area of this shape and the area of this shape and add them together, and you get your overall area. Not a difficult concept, but it is important. So here's the two most important things for this section at this moment. What you're going to be doing is you're going to see the two different, there's a postulate and a theorem. You've already seen these back in the day, I understand that. But these are the two important things that up to this point really should go in your proof portfolio, along with the simple little definitions. But this is an important one. Postulate, area of a rectangle. Here's the formula. Area of a rectangle equals base times height. So the B stands for the base length, the length of the base, length of one of the sides of the rectangle. The H stands for the height, length of the height, whichever one it is. I know, you know the area of a rectangle to be length times width. I gotcha. That's back in elementary school. Forget the L, forget the W. What we're doing now is base times height. You're going to see B and H throughout the entire chapter, including the next chapter as well. So B and H, and by the way, it doesn't matter what the base is or the height, it's just one of the sides of the actual rectangle. Doesn't matter. It comes into play in other pictures, distinguishing what the base and the height is, but this one it doesn't matter. So down here, Theorem 99, area of a square. What we remember about a square is it is just a more specific kind of a rectangle. But here's what's cool about it. As you see, the formula says area of a square is S squared. The S stands for the side length, only one side length because it's a square. And you remember this, with a square, since all the sides are the same, if we label it as B here and H there, the B and the H are exactly the same. So they're interchangeable, it doesn't matter what it is. So that's why they put an S here. They just distinguish it because it's a square. So they take S times S, base times height, and S times S is just S squared. So that's it. So I'm going to wrap this up, and we're going to do a couple examples right after this.